So, it seems we're largely complete. Is there any competing event going on? No? Cool. Okay. So one thing we didn't talk about in Android yet, we talked about a lot of different topics that were very related to Android, and some that were literally related to Android, and some that are unlegible. So I'll probably dim the lights. Is that the suggestion? Yes. Okay. Right. Otherwise, I need your help here. So that's interesting. Does anyone prefer that mode, apart from the speaker?
That's fine.
No feedback is there you go. So so animations on Android. So we talked about a lot of different topics, and I think you guys are well into, or not even perhaps even done with your assignment or your projects.
Get on.
Okay. Apart from the graphics people that have clearly defined priorities. Of course, everyone who's doing a bachelor right now, they also have clearly defined priorities. We should acknowledge that. But so one thing that is a bit that we haven't talked about yet, and it's more on the aesthetic side of things, but I think it's still worthwhile highlighting, is animations on Android, because you can obviously have a bit more of a dynamic user experience on the device if you want, and this corresponds to the material design specifications by Google as well. So the idea is to use some sort of animation within certain confines. But the reason why I'm pointing it out is that there are, as usual in life, multiple ways of doing it in Android, and there's generally the right way and the not so right way, and we want to ensure that you guys know the conceptual differences between both approaches, and then briefly look at them, so get some intuition. So, and if you feel like it perhaps can be something you can use to refine the aesthetics of your project at the end, if you feel like it. So, but of course, it's your choice. Animations, what's that for you? What do you expect when we talk about animations?
I'm thinking like buttons. Whenever you like press UI elements, they do something to give visual feedback that, oh, shouldn't you press them?
Cool. Yes. Thank you very much, because I was worried you were taking on my animations talking graphics, which is a different problem, right? So we talked about animations there last week. But yes, that's right. So we want to have animated elements mostly, right? So how can we do that? Perhaps also how can we work with transitions? So some of the aspects that we're looking at is the dynamic behavior that we can model within activities. And surprise, surprise, most of the concepts actually boil down to stuff you may know from graphics anyway, which is modifications based on translation, rotation, or scaling of elements, right? So that's the fundamentals it boils down to. But of course, on different abstraction levels, there are other ways of dealing with this. So there's a lot of relationship there. In addition to animations, another important topic is transitions, and it's probably I think the word nightmare captures it quite well, and in the sense that, again, there's not one single way in Android of doing it, and I'm not talking about the Java way versus the XML way. I mean two distinctively different ways in addition to their corresponding XML and Java representation. So it's a bit of confusing there. But what I want to talk about is basically the very pragmatic ones, the ones you can quickly implement and use in your applications without much conceptual redesign or rethinking. That's the idea. But one of the aspects about animations more on the conceptual side from a designer perspective, and again, I'm not a designer, but I think we still need to obey some of the basic rules there, is to be somewhat focused on the essence, right? So animations should, as you mentioned before, highlight, should support, should guide the user, provide focus, inform about the navigation order, what is expected next. Perhaps be able to substitute a wizard-style application by having good animations that guide the users and shift his or her focus towards the right thing, right? So I found this on a blog online. I felt it was quite capturing the key challenges that we often have with animations. It's quite easy to overdo it, right? So if you have too much blink and flashing going on, the laws of physics, they need to be realistic to some extent. Again, very important for the graphics people. They need to resemble something we expect. And yeah, they should basically be invisible other than guiding the user. So that's one of the key aspects there.
Can I just
Yep.
point out?
Please.
I used Android for like quite a long time, and
Yep.
Even this specific version of Android that I'm using right now, I've used for like over a year.
Yeah.
I did not notice until like a month ago that like half the buttons I push are like change the icon that's animated when you push them, like in different tabs. For example, the alarm clock app.
Right.
Like there's an animation and it's like, oh, holy shit, has that always been there?
Well, but I think that's because you absorbed it into your intuition, right? You expect that from buttons, so you don't see it. It was not the sparkly, fancy feature that you suddenly observed, because you probably would observe it if it wasn't there, right? So it was one of those hygiene elements where you feel, did I press or didn't I press? You want feedback, right? So in this case, it was about user feedback, and that's right. So, but you can do a bit more, and you can actually push it quite far, ridiculously far. But you know, we'll have a look at some aspects that are relevant. So again, you need to obviously also choose the right element for the right job. I'm not suggesting whatever we're doing later may not necessarily imply that we're doing the right thing, because we're just trying out animations, right? But when you develop your own applications, you want to be sensible as to, you know, how much animation or some sort of dynamics do you want to introduce into your model, right? Does anyone recall the blink tag in HTML? It's another nice anecdote. No?
The blink tag?
Ah, there you go. The previous generation. There you go. So what's the blink tag in HTML?
Next text blink.
Yeah. And what happened to it?
I'm not sure actually.
Right. Okay. So the blink. That's again. It was N90s, beginning 2000. So everyone who was able to make a website, you know, and wanted to, you know, show off, had some blink element in there. It was those flashing ads or whatever. Oh, there you go. Yeah, you catch my sentiment here. So it was literally every page had some splashy and then neon colors, and you know, it had all the resemblance of ridiculous advertising that we're used to from the late 90s. And it turns out that this tag actually could spark epileptic attacks. So you know, so because if you have a sharp contrast and the blinking rate was too high and so on. So in the end, it was considered a nuisance of the HTML standard and ultimately removed. So most browsers don't support it anymore. IE has never supported it. Firefox removed it completely quite some time ago now already. And the inventor himself said it was the worst thing he ever did to the internet. So, and that says something, right? So that says he insists up to today. He only had the idea, he didn't implement it. So that's still one other aspect. But so they are bad examples of what you shouldn't do. So sometimes functionality actually gets removed, right? Instead of added to the framework. So the idea is there, if in doubt, don't do it, right? So if you feel like you're doing animations for the animation's sake, then you probably should abstain from using it in the first place. It's the one thing. Yes, of course. And the other aspect is, in terms of wasting time, animation should be short-lasting and very efficient and actually focus on what you want to get across. So, and in Android we can do that, so it's no magic there. And there's two different types of animations that we deal with. The first ones, the older ones, that's why we'll be introducing them, are called view animations. And the idea is there, as soon as you, in week 4 or something like this, Mahesh talked about the view hierarchy, you recall, right? So buttons and all the elements that you're using inherit from the view class and correspondingly its properties, and which includes, for example, positioning, positioning mostly in orientation. And the idea is here, okay, can we have a generic animation framework that operates on any view object, basically? Yeah? And that's precisely what the view animations were about. They support basic functionality, such as rotation, scaling, transparency, for example, timing, and elements of repetition as well. And they're generally accessible quite easily using the view, the animate method on the view, in order to get access to the functionality. And I'll briefly highlight this one if my machine permits. We'll see that in a second. So in preparation for that, not to waste time with unnecessary things, I came up with an incredibly intuitive user interface consisting of literally 4 buttons that don't do anything. There was an animation there, by the way. Thanks for highlighting. So, but moving on from there. So let's build some animations. So the idea is here, we have a user interface, 4 buttons. We just play around with this, and they are linked By the way, I didn't. Why is that happening here? Why do I get the warnings? What didn't I do?
I haven't gotten the strings in their own file.
Good. So I actually didn't encode the strings in the string file, but actually hard-coded them in the buttons themselves, right? Which is not good because
Locals. Locals.
the
So,
locale, yes,
yeah.
the internationalization, right? So it's I can't translate them, right? So if you suddenly want to have Estonian or I don't know, any other language of choice, then you're suddenly screwed. So okay, not a good idea. So we learned that. Lesson number one, reflection. So and each of those buttons is has the on-click functionality, which is linked to start animation. So what am I doing there? We have start animation here. We have the views being passed as a reference. So what can we do? We can buttons have unique identifiers, so we can just switch on their ID. And just have some case. I could have done it before, but since I haven't, we'll need to do it now. ID, and then we have button 1, and we copy that pattern a few times. And another time. Good. So let's adjust the and the last one. So then we have unique identifier. There you go. Cool. What am I missing?
Button 1.
Bitte? Sorry?
Button 1.
The bottom one? Well, I'm missing the default statement.
I'm
Right?
just making fun of your naming convention.
Yeah. This is not a convention at all. This is whatever. Yeah. Okay. Let's be evil and suggest unknown button ID. So, okay, cool. So we have all 4 buttons that are identified in some weird way. It's not central to get that right. But the idea is here, if we have now a button, which in this case should be button 1, hopefully, we should have access to a animate functionality, and that is gives a reference to what is called view property animator, I believe. Hang on. Yeah. View property animator, and that provides you with quite a bit of functionality. So and we can see quite immediately, okay, what can we do? Well, we can rotate x by that's in degrees, so 45 degrees. That probably looks horrible. What else can we do? We can scale it factor 2 along the x-axis. So. And you can set timing as well. In fact, you need to set the timing because that's one of the key elements of timing, right? You want to have some sort of changing. Well, that's how all the systems work. You have changing state over a time frame, right? So you need to specify how long it takes to actually perform that transition to have, so the system can interpolate the different stages in between, right? So the value changes incrementally. So let's say, wrong one. So let's use 500 milliseconds and just see if that thing actually works. As usual in Java, you kind of need to be quite explicit in that you say start or start, animation. We call that from threads, for example. You also need to ensure that you explicit about it, which is convenient, but sometimes a nuisance as well. It means you can set up components independently from their execution, which is quite convenient. So let's just see if this thing actually runs. I think the first time will take a bit, so now we have some serious, okay, I do this care. Okay, so now we have the button doing something, right? So we have some sort of rotation along the x-axis, which is inherently beautiful, and we have a scaling effect, right? The button became larger, right? So far so good, everyone can retrace it, right? No magic. So that's available for any view object, right? So if you have a button or other scrolling elements and so on, you can just perform that or untitled and so on. So it's a lot of options there. And in this case, but is there any other functionality that I wanted to highlight on the animate in particular? Of course, you can cancel those ones as well. And you can set up listeners, which are quite handy. They actually allow you, for example, to listen to an end of a animation. Likewise here with end action, for example, upon the action or the end of an action, you could do something, right? So first you play the animation and then you do whatever you want to do. For example, open a new activity. So we actually have time to look at the animation before shifting, for example, launching a new intent and starting a new activity, right? Otherwise, your animation would be obscured by the newly launched application component. Yeah.
The button, what happens if you press it again and again? Will it just continue rotating?
Good one. Without compiling, so let's see. So anyway, the button is still pressable, but in this case, no, it doesn't go further than that in this case, no. But I think I find a case we can. Yeah. It's a rotation. Hang on, is it rotation by? Yeah, actually should continue to rotate because it's not rotation by. I'm calling. That's actually a good observation. So,
No, you're setting rotation, so the rotation is equal to this. If you rotate by, you keep adding the rotation.
Ah, right. Okay. Yeah. Cool. Then inverted interpretation. Yes, sorry for that. Let's just run that thing and see how it goes. I'll remove the end action because that's secondary now.
Well, that's my guess, I guess.
Well, from the original position, yep. But this point is good. That's a challenge that you can face. So, yep. So that's now you have the effect, and it's inherently beautiful, right? And probably not something you wouldn't show anyone ever. So,
yes.
knowing this now, so this is basically the view animations approach. So quite straightforward, right? So view.animate, and then you stuff whatever you want, and then whatever you set up the timing and then look at it. But what are the problems? There are some inherent problems built into it. And one of them is actually quite slow relative to the alternative approaches that are available. And this is mostly due to the reason that it doesn't use the GPU functionality, right? So it's written, I'm not sure when it was introduced. It was one of the very early versions of Android, the animations framework, the view animations framework. But it didn't support any sort of 3D acceleration or the like, whereas the modern animation frameworks actually make use of it.
How much of that do you even have on phones?
What?
Like, you don't have dedicated graphics on your most phones.
Not on most, but you can, it's increasingly built into the actual CPU as a component, right? So, and this hadn't been made use of at all in using the earlier animation framework, at least from Android itself. So, but now we're talking obviously about more complex animations. This is kind of very simplistic, right? Straightforward. Its advantage, of course, is, and that's why I show it to you, is the compatibility, right? So it pretty much works on all Android devices, like going back to version 2 something. Downside, of course, is also the fixed API. So you have, animate, and then you have this functionality, and that's pretty much it, right? So we saw this few methods available. And in version 3 of Android, API shoot me, I don't know, quite some time back, this version was actually never really properly released in mobile phones anyway, because it was only focused on tablets. They introduced the idea of property animations. And here the idea is quite a bit different. So instead of only looking at views and hard-coding it towards their particular properties, the idea is, okay, why can't we have a system that pretty much constantly or repeatedly polls the state of the individual UI components and redraws them, right? So the idea is we're no longer actually necessarily driving the animation itself, but actually just driving state changes or property changes of UI elements. Yeah, so we're changing their state over time, of course. So from an aesthetic point of view, it's the same thing, but the underlying approach is quite a bit different. It's actually quite neat as well. So the difference is here that instead of having a fixed API, well, of course there's a fixed API, but instead of having a hard-coded set of possible animations, the approach here with property animations is that it's able to inspect quite flexibly any kind of object you think about. So it's no longer constrained only to views, but any property in principle, well, nearly any property of any object that you probably have. And it may also extend to objects that actually are not visible. So you can modify state changes for an object that's, for example, in the background. For example, because you want to show it later on, right? You have it invisible, but you change its position to make it visible later on. This is entirely possible using property animations. The functionality is roughly the same as we had before. So we have some view animations with view animations such as duration, repetition, and things like this. I didn't show that yet. We'll get there. But what's more interesting, actually, now you can actually construct sets of animations and combine them more cleverly, more systematically, to actually have a more, orchestration functionality. So you have no longer just individual interactions, but actually interaction amongst different animations. So we'll see that in a second as well. Probably, hang on, what did I want to show? Was there anything? I'm not sure how that got in here. Anyway, cool. So yes, so the idea there is slightly or quite a bit different. Actually, it's a bit more involved, but if you plan to use that mechanism in the first place, then it's probably worthwhile not so much just to rely on the view animations, but actually use property animations if you can. And the idea is quite straightforward. So your attack point is totally different. Instead of looking at the individual view, you actually start with the animator itself. Let's call that thing. Yeah, let's do some. Probably you have more than one. So and now it becomes interesting because now instead of thinking about views or applying animations to views, we need to look at objects and their properties. And how we do it here is you basically can do things like that. So we have, and I'll get to the idea in a second. Sorry, yeah, I will increase the font. That is in high. You're right. I should do that. That's a very good point. Better, ish. Can put it a bit more. So that's a good idea. So Scalix. What else do I need to do? I want to have obviously a factor by which I want to change something. Let's say factor 2. And then we say animator start. Okay, so any observations on this statement? Easier, harder, complicated?
Is the property name just any member the object has?
That's right. So the key difference here is your observation is good. Is that the property name is indeed a member of a object, but the only constraint is that this object needs to have a getter and a setter, because that's how it interacts. So it's basically what it does when you give it an object, it will use reflection, Java reflection, to expect the object and explore all the get and set functionality it has available, and will commit this as a property name string in this method, for example. Yeah. So you could, in principle, well, access any of those properties. No, any of the properties you can get and set. That's the key thing, right? So you could set it activated, deactivated, set the alpha animation. Careful with booleans. There is a bit of an issue as animating booleans because they only have 2 states, so you can't have nice interpolations. I haven't found a way of integrating this into animations properly, but yeah, there's only hex around it. But in principle, any method that or any property, any member that is governed by a getter and a setter, or mutator and accessor, if you like, can be modified this way. All right, so let's try that one. Let's see if I got it right in the first place. And get rid of this down here. So I remove all the view animate stuff because that's just confusing. So that's the old way. And this is the newer, somewhat cleaner way at least more generic way. It again falls into the pattern that Android kind of, in Android everything is kind of a bit over-engineered in a sense that it has a proper extractions and flexibility and open-ended usage in mind, as opposed to a hard-coded set of functionality. So let's see what's happening here. Yeah, that's kind of worked, right? So we have the scaled buttons and we scaled it along its x-axis, so quite neat. So, okay, what else can we do? So let's see if we what can we do? Float. So obviously float values are the most sensible because of their continuous nature for modification. But for example, we could also, now I need to check. Ah, that's actually quite nice. So I didn't know there's code completion. It doesn't suggest anything. So half of the time I find myself looking actually at the API of the object in order to see what we can meaningfully modify. So translation X and so on. See if we can do, just move it up blindly. Cool. So animator start. So. All right. So we now have hopefully two animations that are somewhat played successively. So. So we basically have a simple button that's flying out, right? So yeah, something you can do, of course. But first of all, I didn't specify timing, so it was way too fast. So for this one here, we probably set duration to scaling for, let's say, 100, and for the other one, we set the duration to 500. So half a second, which is very long. Again, bear the user's time in mind. This one will probably waste his time, her time. So, did you? I'm not sure if you have seen that, but any intuitions as how we could improve that? What do you observe if you carefully look how it behaves? Is there any intuition as to what could be improved to make this animation appear more smooth? It looks a bit rugged, right? No?
Slurping.
Slurping, okay. So right now, we're basically sequentially executing two animations. So what would be desirable? Possibly? Combine them, right? So, yep. And probably the most sensible one is to start perhaps off with the scaling element. Right now we only scale along like the x-axis, and I believe the view itself doesn't have an option to set the scale across both axes at the same time. So let's introduce that first. Check animator 2. I'll just name that thing. Let's call this translation. Animator 2. Float. View, and we now hang on view, and we do the same for Y now as well. Double the size, and we set duration. And start it. Hang on, that's way longer. Not sensible. So, incrementally. Right. So actually, that looked fairly okay-ish, but you still see the ruggedness of having the sequential execution. I'll just show it again. And it nearly looks, yeah, it kind of looks in sync. But the idea is, the basic idea of actually orchestrating functionality more systematically is to basically use animator sets. That's the idea. Yep, animator set, and we call it set scale, and this animator set, and this allows you then to indicate how they should actually be played. For example, you can play a single animation which is not really surprised sequentially, or play them together. So that would be the convenient way of bringing different animations and executing them at the same time. So again, just as a reminder, you will need to be explicit about starting them. So just playing them together is not enough. Because you can introduce pretty much an arbitrary level of complexity. For example, what you can do as well is, hang on, get rid of this one. Introduce another animator set. Fly out, scale, and fly out, which basically is a combination of both, right? So play sequentially, or even play together, and we combine the scaling while at the same time doing the translation. Sorry, it should have been down here. And scale and fly out, and you actually start the execution. So I think you get the principle. Relatively straightforward, and see if it actually does what's supposed to do. So it should have played it together. Again, it's a matter of playing around with the durations, because the zooming is now way faster than the actual translation. So if we synchronize them, then we should have a more continuous motion of scaling and flying out at the same time. Yeah, so now we have kind of a continuous move as well, just to make it slightly more annoying and to ensure that nobody will use the app again. Animator rotation. So, animator offload. Let's do some rotation. So hue and use rotation. Let's rotate among whatever, one of the axes. Let's take the x-axis, and let's take 360 degrees. And to make it a bit worse, we can not only set the duration, but so let's make it turn long. Animator duration. Set. Set repeat count. So let's repeat this thing. Let's say 5 times. So, cool. So with the animator rotation, we play everything together. We have the animator of translation. Let's add this animator rotation here as well and see what we get something that looks somewhat unappealing. Ah, that was too slow. That duration, it's too slow. That was very fast. But you get the gist of it, right? So you can have rotation, and you use just mechanisms to kind of speed it up, speed it down, so you get the desired effect. So if you want to have a flyout effect with rotation and ideally some scaling at the same time, let's actually link that to button, I suspect button 3, which is, and shift that one to button, so we can have the functionality a bit more explicit. Oh yeah, good. So my translation was not enough, but now it rotates 15 times and stays there. So let's be more giving with the translation here. The problem is I haven't found a way of providing the layout independent pixels, device independent pixels here, because it explicitly expects the float value as part of this. But anyway, so we have a fly out effect. What's the problem now? No problem?
Doesn't reset.
Yes, that's precisely one of the key problems. So following the intuition of having an animation framework, you kind of want to rewind the whole thing, right? So you can quickly go back to your original state. This is one of the things that's also not super straightforward. Even though it's somewhat available in the API, it actually doesn't really work. So there's a bit of a detour you need to take in order to make that happen, but it's possible. Yeah, we'll do this later. And the idea is that you use the interpolation functionality that's actually provided out of the box. So interpolation means how can I vary, for example, the behavior over time? And one of them, and we can use this functionality to actually undo some of the nasty behavior. I have some codes, so anyway, I'll just quickly retype that. I need the constructor, it doesn't offer me one. Interpolation. So interpolator takes a interpolator object, your custom implementation takes a interpolator object in the constructor, and then you can assign it to your field in this particular case. And do we need to have a default one? We probably need a default constructor as well. In this case, okay, and the key thing there is to actually undo the functionality by, performing the operation basically backwards. So let's see, override. So ensure I get the method signature right, which I didn't. So
You have to implement it.
sorry.
You have to implement the interface. It's not specified.
You mean the parameter, or what did I?
The implements statement.
Ah, right. Thank you. Ah, good. Thank you very much. Your perspective is a bit better up there. Just directly implement this one. Linear interpolator. That doesn't work. Now where did I get this from? They actually borrowed from the View animation package.
You have to implement the methods.
Did I make it worse? So there you go. Cool. Implements or extends implements interpolator. Interpolator is referenced. and it just misses some. Yeah, okay. Again, interpolation is the method, and not get interpolator. There you go. So, cool. And then you just yeah, reverse interpolate the whatever you got as a value. So, and this thing can then be used in your code. Right, and you need to have some listener for that purpose. This would be, just need to peek on my cheat sheet here, so there you go. That listener, there you go, this was the one. New animator adapter listener, that's the one. So, right, so you can interact with the animation as well. So by attaching a listener to it that you know, can be executed at the end of it, whenever repeating, when starting animation, or even when canceling it, and so on. Right. So in this case, we would need to have some functionality that sits at the end of the actual animation. And yeah, so we take the animation and first of all, we ideally remove the listener itself again, because otherwise it would be played up on the end of the undo animation again. Then we immediately start, so we don't wait. And the key thing now is to actually say set the interpolator. Interpolator, and that's the reverse interpolator. Oops. And of course, to start it. Cool. Before that, let's complicate it a bit further. One thing that that's one. Let's see if it works anyway. So we basically tell the system, okay, at the end of the animation, whatever you do, undo it again, and hopefully bring the button back, which it doesn't. So let's see what I did wrong. Right, I started the animation before I added the listener, which will not get me very far. So. And this one either. There you go. It was actually coming back. Okay, so that's one way of actually undoing the animation functionality. So it's not like super intuitive, and I think it's something they could have easily thought about and actually introduced into the API natively, as opposed to kind of rewriting it manually in a way, which is a tad tedious, I guess. So things that don't really work well is dealing with alpha values, surprisingly. So animator alpha float, and for example, if we change the alpha value to 0.5, should be a float value. Did I get this? Yeah, cool. Animator alpha, let's introduce that thing as well. Okay, I need to work on the timing. Anyway, after, do we see a difference in the buttons? Actually, view alpha, set the property view alpha. Is view alpha specified? Alpha. Duration. No, I don't think it changed the alpha actually, so I may have gotten something slightly off there. So let's see. Saturation. Play together. Anyway.
Isn't it because
Did you see it?
if you reset the entire animation within careful layer, will it go back to full?
Yeah, okay, if that worked, then I'm really happy because it never worked before.
Duration longer.
So let's try that one. Yes, and fact, let's just because I had tried that before, and that's really I struggled with getting that going. So let's just run the other animator alpha just to see that the animation, the alpha actually works. So, and if it does, then that was good. Would be better. Cool. Then the interpolation works there as well. The reverse interpolation. So yeah, that actually does something. So probably your hypothesis sounds reasonable. So cool. So it seems to do its job. So no need to worry. Okay. So, but in any case, what would you do if you if the animation doesn't really do the reversion properly? Any ideas what you would do? Yeah, it does. Well, you need to manually fudge it somehow, right? So as part of this listener, right? So you can do afterwards and change that there as well. Okay, 5 minutes break for you guys, and after the break, before I want to briefly go into transitions. So that's kind of intuitive right now, I guess. You can play around with this, but I want to do the evaluation meeting, similar to what Marius did last time in class. So that is the idea. So we capture this essence as well because we need to get the information before, before the end of the course, right? Which is moving in quite soon. So 5 minutes break, or somewhat there, and then we have a bit of an evaluation meeting.
Oh.
Do you need more break? I no. Oh.